want to introduce John Vradenburg. He came up from central New Mexico. He's a supervisory biologist at Boston Apache National Wildlife Refuge, which is a premier wildlife refuge for wintering ducks, geese, and cranes in the Southwest. I started working with John, I think it was about 8 or 9 years ago. I worked for him. He was my boss. And we managed, I forget the numbers, about 3,000 acres of moist soil units. It was a 70,000 acre refuge. Boston Apache is lucky to have a very good water right down in New Mexico. So we're able to do some very good wetland management down there. But John has excellent training as a student of Lee Fredrickson, who basically wrote the manual on moist soil management. He's going to be speaking about, his first talk today is going to be about waterfowl ecology, and it's to kind of set the stage for why we're doing what we're doing to do moist soil management. So you need to use this button or the wheel.
Yeah, like Colin said, I'm from central New Mexico. I wouldn't say we have a good water right. There's no such thing as a good water right in New Mexico. It is New Mexico, so we use the system to the best of our ability. But the way our water right works in terms of the Rio Grande is an unadjudicated system. It's one of the only unadjudicated western systems, and so our right is right under the Pueblos. So there's prior and paramount water, and then we're topping the line, but we're at the bottom of the system, and one of the irrigators told me I'd rather live at the top of the ditch with the bad water right than the bottom of the ditch with the good water right, and that really fits for where we're at because we just don't get the water a lot of times based on the ag demands. So I'm going to talk about some basic energetic waterfowl needs to set the stage for the moist soil stuff we'll talk about here in just a little bit. And I tried to focus on energetically what birds here in the Platte need throughout the annual cycle. And it's important to always be thinking about that annual cycle and how you provide the foods, because it transitions throughout the season for what they need. And these wetlands have the natural capacity to provide those needs if we just stimulate the system right, which we do through the moist soil management. So I'm going to follow up with what Brian said again. We follow the same mantra down there. You're doing localized management, but that localized management is affecting a continental resource. And so we always try to keep that in mind, whether it's providing food or it's managing the disturbance or whatever we're doing, considering that resource, it's only on us for a short period of time, and somebody else they're going somewhere else to do something, somebody else is utilizing that resource. And so when you're talking about successful management for waterfowl, you're talking about managing energy. We have to manage, they're managing energy within their budget, and we're managing energy on the landscape to make sure that energy is available. So I look at it from, we try to provide energy, we try to help them save energy, and we try to manage their account a little bit on how they spend their energy. And so that really comes down to how we manage disturbance on the landscape. There's a lot of stuff they do within their life that costs them energy, but there's things that we do out there that force them to use their energy differently than they probably would under natural conditions. So our job then is to find that balance that promotes good body condition. Good body condition is going to facilitate the next move in their life cycle. It's going to facilitate the stuff we like to do on the landscape with them. If you keep birds in good body condition, they're going to stick around. If your objective is to manage for public hunting opportunities, if they want to stick around, you're going to increase public hunting opportunities. For us, public use, visitation, photography, and wildlife viewing is a big issue for us, so we don't want to get the birds stressed out and leave, because that affects one of our primary objectives of keeping birds after the photographers. So it's finding that balance between these three things that's our core job. And so stepping out again to this continental scale, we're in the Central Flyway. Everybody understands the Central Flyway. But realistically, that's just a political flyway. The birds do all kinds of stuff throughout their year that doesn't really fit within the boundaries we put. But here in the Southwest, managing these southwestern systems, the key to remember is wetland resources are really limited. If you go north and you go south, there's a lot of wetlands. When you sit here right in the mid-continent in the Southwest, wetland resources are a limited thing for these water birds. And they're limited throughout the year. There's different periods of availability and lack of availability. And we can really key in on that and make our management more effective by understanding how that availability functions on the landscape energetically for the birds. Okay. That was a mistake. You really don't want to hear me. Is it on? Is that working? Is that better? Okay. So in the fall, we have this big breeding thing going on up north. So there's lots of recruitment, lots of new birds. Population is bigger than it is throughout any other period of the year, and they're all coming down from the south. Those of us that live in the Southwest, we understand, I mean, what's the big driver for wetland availability this time of year for us? What happens here every August? Anybody? Monsoons are the big driver for wetland availability. You know, it activates the playas, it puts water on the landscape. It makes this huge wetland availability throughout the Southwest. So the birds come down, and they've got a bunch of wetlands. And they trickle down through the wintering grounds, down into Mexico or southern U.S. But the spring is a different story, energetically speaking. So, you know, here we deal with high winds, lots of evapotranspiration going on, wetland availability decreases, wetlands dry up. There's just not as much water on the landscape in the spring. So we get these things we call energetic bottlenecks. And in the Central Flyway, there's a couple key energetic bottlenecks. Through central New Mexico, and then the Front Range up along you guys is one of them. And then when you go out to like the rainwater basin area of Nebraska on the Platte there, it's another one of the big energetic bottlenecks. So the birds are coming up, this big population of wintering birds coming off of the wintering grounds, and they get squeezed into these pinch points of where there's a few wetlands or there's good energy on the flyway. And then they spread out again into the breeding grounds. And so this is where our managing those resources become really important for water birds. And this ties into something called cross-seasonal effects. Not everybody believes in cross-seasonal effects. I'm a pretty strong proponent of cross-seasonal effects, but I work on the wintering grounds, so I need a reason to justify my existence. So I believe in cross-seasonal effects. But what cross-seasonal effects then is that there's a cumulative energetic demand throughout their annual cycle. And each annual cycle event then is then reliant on how successfully they made it through the previous event. So when you look at most waterfowl, this is a rough diagram of their annual cycle. They nest, they raise their young, they go through their molts, they migrate, they winter, they go through courtship, all those things, and then back to the breeding grounds. And when I talk about cross-seasonal effects, I know that's pretty small. But what we're talking about then is each one of these periods is only going to be as successful as the previous one. So if you start out on the wintering grounds where I'm at, if we don't provide enough energy out there that they can't successfully go through courtship, they can't successfully maintain that pair formation, they lose body condition as they're migrating. As they get up to the breeding grounds, they're not going to be as ready to lay their eggs. So that's going to be, what that correlates into then is delayed nesting attempts, smaller clutch sizes. The longer you delay the nesting attempt, the more likely it is that predation is going to become a higher risk. Second nesting attempts tend to have lower clutches. So all this ties back into then larger recruitment at the landscape scale and overall population management of these species. So, like Brian said, waterfowl use here in the Platte is higher during the non-breeding season. But there are a lot of life history events that are going on here. Even though we lump it as migration and wintering, there's a whole lot of things going on in these birds' lives that require substantial amounts of energy to get them through. So there's courtship going on. Most mallards in the population have started courtship and have formed the pair bond that they're going to try to maintain through the entire cycle by the end of December. There's pair bonding going on. Pair bonding then means you got to protect that mate. The earlier you form that pair formation, the more energy you have to put into maintaining that pair formation. This time of year, with migration just starting, there's molt completion going on. So a lot of the males, they'll initiate their molt as soon as they decide they're done trying to have nesting attempts with females, but the females don't initiate molt until they've successfully hatched a clutch or they've given up on nesting. And so molt completion is delayed, so you have this huge change in energetic need between males and females even on the wintering ground. So the males will be showing up, they'll be just completing their molt. When the females show up, they may be just a quarter of the way to halfway through their molt. So energetically, they're really different. There's going to be, if you're on the wintering ground, there's going to be a lot of this pre-breeding foraging going on, getting ready for the big nesting attempts. Then you got pre-migration staging, foraging. And to just compound it even more, like Brian showed 5 species. Well, there's a lot more species that come through here, though. And each of those species, all these energetic demands and the timing of these life cycle events are all staggered. And they're staggered by species, they're staggered by age, they're staggered by gender. So there's a lot of stuff that goes into all piling into the fact that we need diversity of food habitats out there, a lot of different food resources. So I'm just going to go through, this is a really rough example of how I look at the continent and what we do and how we manage it for these localized events. So we have, if you look at the continent at a broad scale, we've got this breeding area that's dominated by a winter thaw and a lot of winter precipitation, spring availability of wetlands. We have this mid-continent that has these periodic flooding events, but they're high in seasonal foods and invertebrates. And we have the southern part of the continent that tends to get evapotranspiration changes, water becomes available on the landscape, there's a lot of fall flooding, so a lot of water availability, a lot of food availability. And these birds have figured out their life cycle then is tied to this big continental system. So unlike other waterfowl throughout the world that may be more variable in how they use the landscape, our waterfowl are really tied to this big continental climatic pattern. So during the breeding period, they go up to these northern areas. They've got this huge amount of wetland availability due to the thaw and the snow. They initiate nesting, but their food resource they need is bugs. So they go up there because there's this huge protein resource that they can go through nesting, molting, all those protein demanding events that they go through. Here on the mid-continent, I mean, this is kind of key to why loam soil is really cool and why it works for us here in the mid-continent is we have these wet events and these drying events that create these seasonal foods that become available through flooding events. And through the long-term flooding of those events, we get this invertebrate resource. So when you think about how migration works, what the birds are going through, what they need, you have these birds migrating down. They need a bunch of carbohydrates. They got all this food on the landscape. They use these seasonal foods, but as they're going north, their diet's switching to protein because they're getting ready for egg production and nesting. And so these bugs are available then at the large continental scale. So the types of habitats that you guys manage are key to this. We have these floodplains, we have the sandhill areas, playa-type habitats, and these big rivers that tend to overbank and flood. Like I said, they need proteins and they need seeds. This is a little wetland plant. I think they've changed the name a couple of times since this, but it's Rumix dock, which you guys probably have a lot of out there on your sites. And then on the wintering grounds, we have this huge availability of wetlands on the landscape. And they're going through, like I said, they're going through all these life cycle events, pair formation, courtship, foraging, maintaining body condition, and they have this availability of habitats to do that. Well, here on the Platte, you guys have a unique challenge. You guys are really similar to us on the Middle Rio Grande. I mean, it's similar type of river systems, similar type of waterfowl life history things going on, similar management challenge. But you have all of these events going on. So you've got, I mean, there's a little bit of breeding, like Brian said, not a whole lot. A lot of migration going on, probably substantial numbers of wintering from those slides that we saw. Lots of courtship. Those spring numbers are indicating that there's courtship going on, there's pair bonding going on. So you can't just have agriculture. You can't just have a wetland that has one good food type on it that you pull the water off of and it's gone. You have to have this diversity. You need seeds, you need underground biomass, rhizomes, tubers. All of these things have different amino acids and lipids and things that stimulate things happening in a waterfowl life cycle. And then you need bugs. In terms of ducks and geese, not so much. Geese get away without eating a lot of protein from animal foods, but ducks need a lot of bugs. So just to show you the complexity of one species and the timing of the year that you guys are dealing with them and what's going on and how your wetlands are there to meet their energetic needs, we'll look at a mallard. And so there's a lot going on in these guys throughout 1 year, from hatching to when they do their spring migration again. So they start off, they hit the breeding grounds. They're nesting in May. Clutches are coming off mid-May to mid-June. And so they hatch out, little fluffy yellow guys that everybody likes to see. And right away, they're eating bugs because they're only little fluffy yellow guys for a little bit. They have to go through a really quick molt that we call the juvenile molt. They go through that juvenile molt, then they initiate right into their basic 1 molt and then right back into alternate 1 molt. And so in a 4-month period, they're going through several really complex plumage shifts, and plumage shifts require huge amounts of protein. So if you don't have bugs on the landscape, they can't be successful. Again, if they're not successful, they're not ready to make that migration jump because they're energetically stressed. And so if you just look at a juvenile bird, as it's going into alternate 1 plumage, it's still going through that as it's entering into the migration period. So as they're arriving here on the Platte, they're in that plumage transition, looking for bugs, looking for energy to keep migration, but looking for bugs to finish molt. So then if we look at did that fall down? You were hearing my feet, huh? It's the first time I've walked out of a microphone. That's pretty impressive. I'll keep the South Platte in my memories now. If you look at the adults, though, it gets even complicated again. So they go through they enter the breeding grounds, and energetically, this is really stressful for them. Waterfowl have a highly sex-skewed ratio, about 60% males to 40% females. So that means, energetically speaking, these males are spending a lot of energy to secure, hold, protect any pair formation they make, because there's a whole lot of single guys out there that are spending a whole lot of energy to break apart that pair formation, get some kind of nesting attempt with that female. And the females then are spending a lot of energy just trying to get fat and get ready for the breeding period and put on as much reserves as they can to be successful through that nesting period. So energetically, this is one of the most stressful periods for these migrating birds because of all this demand they have from these social things going on in their population. They hit the breeding grounds, though, the females initiate the nest, so a lot of energy going into egg production. They produce about 1 egg a day, depending on species, maybe every day and a half. That's a huge amount of protein that goes in. A lot of energy goes into that egg because they produce a young that can come out and be active right out of the egg. So they lay their egg, they nest for about 25 to 28 days, hatch that egg, brood the young, and then raise the young. They'll initiate that molt, like I said, as soon as the clutch hatches, but it's delayed then. So when you look at the migration, the males will have initiated their molt migration here in July, August, or their molting event. Females won't initiate until, sometimes in August, early September. And you can see the molt delay that goes on there. So right here is another one of those bottlenecks that we deal with in the wintering grounds, and you guys deal with it here as well, is that the females are just finishing that alternate plumage molt. The males have finished it for weeks. They've been alone for a long time, and they're starting to think about that pair formation again. And so they start chasing the females, putting a lot of stress on the females. You start to see the initiation of courtship flights happening in here, so a lot of energetic events going on in their life. So the take-home point with these guys is that there's never a down period. Energetically speaking, they're just constantly burning energy. And this is where these landscapes, these small wetlands that we have throughout the landscape become really important landscape connectors that allow them to be successful throughout that annual cycle. So the reason I wanted to go through all this before we jump into the moist soil event, the moist soil discussions, is so you can understand why we do it on the landscape and why it's important and why each of your lands are important to manage. So It's important then that you manage that habitat in accordance with the life cycle. So one of the things we've seen in Colorado, when a lot of the wetland stuff started, San Luis Valley was a good example of it, is we set really high population goals based on nesting. Well, it's good to have some nesting, but it's important to remember that in the continental scale and the life cycle events of these birds, we're a mid-continent migration. And so if we just focus on nesting habitats, we energetically sort of miss the point of where we need to be in terms of what the birds need and what they need to be successful. And we can cause potential declines in body condition that affect continental populations. And it's important then to understand the larger landscape in the context of managing our wetlands. So, there's a huge representative of a bunch of different people that have habitats throughout the landscape. So you want to work with all of your partners to understand what's missing in the big picture. Do you want a bunch of flooded corn? If all of your neighbors and everybody around has a bunch of flooded corn, is it the best thing for waterfowl and the best thing for managing your wetlands to just flood a bunch of corn? If everybody's got moist soil areas, but there's not a lot of roosting habitat out there, where can you best fit in the larger picture of waterfowl management to maximize the landscape benefit to these birds as they're coming through? And so just to wrap that up real quick, I know there was a lot of stuff, but again, the need is providing energy. So again, how do we do that? We ask the questions of what does the landscape look like? What's missing? What can I provide? How can I manage my lands to maximize the energy? Is it through ag? Is it through a managed wetland? Is it through providing roosting habitat? Saving energy. How do we help these guys save energy? Well, we do that through providing that mosaic of habitats on the landscape. We do that by providing refuge areas so they can get away from disturbance events. And then how do we help them mitigate spending energy? There's a lot they have to do to spend energy in their life, but how do we mitigate disturbance events that cause huge jumps in energy expenditure? And so that's managing disturbance, whether that's seasonal closures, daily closures, rest areas within your hunting area that you rotate around, but managing that ability of your land to meet those needs. And so this is the last one I'll show, but this is just, we look at how birds, or anything, burns energy on their basal metabolic rate. And basal metabolic rate then is simply what it takes to be slightly above nothing. So you're not moving, you're not really doing anything, you're just slightly above maintaining breathing. And so anything above that is costing us something. So even resting is 1.3 times their basal metabolic rate. So they have all these social interactions that go on out there that cost them something. Comfort movements, preening, staying alert, guiding their mate. All these things have cost. But where we can manage stuff is flying. So any additional flying event that happens during that wintering period is energetically expensive. So, for example, on our refuge, we close huge areas of the refuge off so people can't get in and bother them, because people always like to get closer to the birds. The more you push the birds, the more often they're in the air. Every time they're in the air, that's 12 to 15 times that basal metabolic rate. So effectively, if you keep them in the air, don't let them rest, they've used all the energy they were able to get off of your landscape in the first place. So managing disturbance is a big thing with these guys in terms of their body condition. So that's all I have with energetics. I know there's a lot of stuff, but if you have any questions, we can talk about it in the field as well if that works.
Yeah, we're a little ahead of schedule, which is great. So there's time for questions if you have any.
I have a question, John, about, and maybe you're not the guy to ask, but I think so. From a water quality perspective, what do you want to see in your wetland? We hear a lot of debate about it. I've done some great duck hunting in wetlands where you walk in and it's obviously anaerobic,
Yeah.
mud's stinky, terrible ducks in there.
Right.
And there's a lot of debate amongst managers about what are the water quality requirements.
Yeah, I think that's kind of a tough question, because you're right. A lot of anaerobic wetlands produce a lot of really good invertebrate resources.
Well, that's what I was wondering. Is it different seasonally?
Mm-hmm.
When you're trying to produce carbohydrates, you want one thing, and when you're trying to produce invertebrates for the birds, do you want something else?
Yeah, definitely. But again, it all
talk
comes
about that a
down
little
to that mosaic on the landscape. I mean, I think if you have some wetlands that, these semi-permanent wetlands are really valuable in certain contexts of things, and they tend to be those anaerobic wetlands that are gonna produce a certain kind of macroinvertebrate, a bigger bug that, you don't tend to have the microinvertebrates that you see. And so they're valuable to a certain guild of species at a certain guild of time, or a certain period of time. So as long as you have some of that out there on the landscape, that's great. I think what the concern is, you never want a whole lot of any one thing on the landscape. And that's the big concern. I think, even when moist soil was developed, I mean, you look at the history of waterfowl management at the national scale, even, through the Fish and Wildlife Service and state agencies. If you look back 50 years ago, everybody believed the best, all you had to do to keep ducks healthy and good was make sure the breeding grounds were good and manage the rest for good waterfowl hunting opportunities. So we had a lot of flooded cornfields, a lot of flooded ag fields. There wasn't a whole lot of thinking about the other resources we need on the landscape. So we had energetically and life cycle-wise speaking, a not super valuable continental landscape. But then when they switched to moist soil, it almost went to the other extreme. Everybody wanted moist soil habitats on the landscape, and nobody really understood what a moist soil landscape was, and people started converting any wetland habitat that they had to what fit this moist soil model. And I think now we're kind of, as the pendulum's swinging, we're finding more of that middle ground, that we need this mosaic. We need agriculture. We need semi-permanent wetlands. We need these seasonal or moist soil habitats. And so I guess if those are there, by default, you're meeting all of these. You've got the carbohydrates, you've got the proteins, you've got all of it, because by default, you've built enough redundancy in the landscape that it's taking care of itself. And the birds are, the one thing that I always like to say about waterfowl management is we got to remember they have wings, and they can go, they know where the resources are, and they respond immediately. If you've managed a moist soil field or a flooded cornfield, you know that it takes about 5 to 12 hours till those, every bird in the county has found that resource. And they have this just innate ability to know where those resources are. So it's that larger landscape redundancy.
So help me out. You use the term semi-permanent wetlands. What's that to you, and then what's a seasonally flooded wetlands to you?
Yeah, that's. So to me, a semi-permanent wetland is anything that has more than one growing season as a permanent flooded wetland, but it's not always flooded. So like a cattail slough, or even some of these reservoirs out here that tend to go dry could be classified as a semi-permanent wetland. A seasonal wetland to me is anything that ranges from a couple weeks of water to 3 to 6 months of water, and is more dominated by annual vegetation in this area. A lot of seasonals can be perennial vegetation as well, the rushes and stuff, but a lot of the rushes tend to be on the more longer hydro periods, and the annual plants tend to be on the more shorter hydro periods. So the seasonal wetlands are, anything that's not flooded an entire annual cycle is how I would classify it.
So it's either flooded spring or fall.
Yeah, or it could be flooded, from September to March, and that would still be a seasonal wetland. It would be the one that's flooded from, this year through the next 2 years, I would.
When you say flooded, you mean periodically flooded?
No, holding water, standing water.
Yeah, so our sloughs out here would be either permanent wetlands or semi-permanent wetlands. As far as invertebrates goes, those real anaerobic sloughs and areas that hold water year-round can be great sources for invertebrates. And if you're in wetland design, as a consultant or whatnot, if you have the ability to build wetlands with, or if they exist on your area, with some sort of semi-permanent wetland that's connected to a seasonal wetland where you can seasonally bring up the water, and this will recolonize the invertebrates quite a bit faster if it has some sort of water source where the larvae are, and where they're maintaining year round. So you can get better, in some cases, better invertebrate responses if you have they're feeding your seasonal wetlands with water from semi-permanent and permanent sources. So, yeah, I think a variety of wetlands.
Because you've got the larva already and you're just.
Yes,
giving it
so they recolonize, they can recolonize a lot faster.
And invertebrates are kind of, I mean, we don't think about invertebrates a lot as a crop, but I mean, they really are a crop, and you've got to farm them just like you do your moist soil seeds. And so you've got to think of that crop going through, you know, as your plant matures and your plant produces seed and you make that seed available, then as you're flooding, the invertebrate response is starting. You know, as soon as the water goes out, something's going on in the invertebrate community. And that's really key then too, as well, to how the resource is available and how the birds can find it. So early on in the season, you tend to have if we went out there now and did sweeps of wetlands that had been flooded for a couple weeks, you're going to find a whole lot of really small bugs. If you go out and you do that same sweep in that same wetland in the spring, you're going to see those bugs have matured, and then they're a different protein value and a different energetic value. You know, and some of the species that Brian showed out there, I mean, you have a bird like a mallard that is really generic in its diet. I mean, they can eat anything and get by on anything. Or you look at something like a blue-winged teal that's more of they're an invertebrate or really small seed specialist. Or you take it down to a shoveler that's really an invertebrate specialist. So, you know, just built in the ecology of waterfowl and the shape and form and use of wetlands that waterfowl have, there's this huge partitioning of resources as well, you know, let alone just the energetic partitioning that we have. So, again, I guess it all goes back to diversity on the landscape. If you want a bunch of shovelers, have a bunch of anaerobic wetlands. If you want a bunch of mallards, have a whole lot of different stuff on the landscape.
Okay. Thank you, that was very helpful.
Yeah, John mentioned San Luis Valley, and I think it's worth mentioning he's got a good connection to Colorado. He was a Ducks Unlimited biologist prior to working for Fish and Wildlife Service, and he worked down in the San Luis Valley, but also worked with Greg and the Ducks Unlimited folks up here in the South Platte doing field visits. So he's got a good connection to this area as well.